Hello, I'm Terada from Kobe University. So this presentation is a final report for our project named Interaction Platform based on Psychological Informatics for Information Presentation. So first of all, I'd like to show some brief video, our project video. Sorry, this video is spoken in Japanese, so please
我々の研究
see
プロジェ
the
クトの目的
subtitle.
は定時系心理情報学という新たな学問分野を構築することです。近年ですね、こういうウェアラブルデバイス、ヘッドマウントディスプレイとか、こういう VR のゴーグル、AR のゴーグルなんていうウェアラブルデバイスがたくさん出てきています。こういうものを使うとですね、常時こう情報を見る環境っていうのが、当たり前のものになりつつあります。我々はそういった常時情報を見るような環境において情報を見ることが僕らの心身に一体どういう影響を与えるのかということを明らかにしていくということが目的になっています。我々の研究プロジェクトは3つのグループからなっています。まず1つ目のグループは僕自身テラダのグループで、ここはですね情報提示の理論化および評価のためのセンシング技術について取り組んでおります。でもう1つのグループが細田グループと言いまして、こちらは MRI の計測技術を用いて心理効果のスクリーニングを行うという技術について取り組んでいます。で最後が柳沢グループで、このグループは実践的な応用として特にエンターテインメント技術に注目しまして、こういう情報提示の技術を実際活用していくという取り組みをしております。テラダグループでは情報提示技術の理論化をテーマにしています。具体的にはいくつか成果が上がってまして、例えば虚偽の心拍情報を見ると自分の心拍情報が動いてしまうであったりとか、周辺視野に、刺激を与えると人間の時間感覚が狂うとかですね、そういった理論をたくさん計測評価しています。でそれに加えて、その計測のため評価のためのセンシングデバイスについてもたくさんものを作ってまして、例えば鼻の穴の中に温度センサーを入れることによって、呼吸を計測してですね、で呼吸のタイミングから、ストレス状態まで計測するようなセンサーであるとか、あるいはストレッチセンサー、伸び縮みを計測するセンサーを使って、膝関節とかですね、体のモーションを記録していって評価に使うデバイスといったようなものをたくさん開発しております。
私たちのチームでは脳情報を利用して情報提示をされた時の影響の個人差というのを事前スクリーニングする技術というのを開発しています。具体的には高性能な MRI の中で1時間くらいのをじっくり計測してその後解析することでその人の特性個人差みたいなものを明らかにします。ただ一つ気をつけなきゃいけないのは、脳は可塑性といって特性とか能力が変われば脳の方も変わるという要素を持っているので、その都度脳を撮像する必要があるっていうこととともにですね、逆に言えば脳を変えることで特性を変えることもできるということができるので、私たちのチームではそこまでをカバーするような研究というのを行っています。私たちのチームはまず VR を利用した際のトレーニングの有効性個人差のスクリーニング技術ということを介入しました。具体的にはですね、視覚介入だったりとかスポーツ介入っていうものを VR を通じて行ったんですけれども、そうするとですね、 VR によってその介入効果がある人とない人というのがきれいに2群に分かれるということが分かりました。でその2群何が違ったかというのを脳の方から、検証してみたところ、脳構造あるいは脳機能というところに特徴的な違いがあるということが分かりました。つまり事前に脳を計測してその情報を解析することで、その人たちが VR に重要性がある人なのかない人なのかというのをスクリーニングする技術が確立できたということになります。これは特許申請も行っております。
私たちの研究グループでは視覚的な情報に混入するノイズが観客に与える影響について研究しています。ディスプレイなどの表示装置の一部に故障が起こると表示される内容が崩れてしまい、見たりる人に違和感を与えてしまいます。しかし情報の表示方法を工夫することでこの違和感を大きく減らすことができます。提示される情報にどのようなノイズが混入すると人は違和感を覚えるのか、また情報の表示方法をどのように変化させると違和感を低減できるのかということについて研究しています。私たちはこの研究を見かけディペンダビリティと呼んでいます。違和感を感じるメカニズムを解明することは、人間が芸術作品を見て美しいと感じるメカニズムの解明にもつながると考えています。
I'd like to continue the presentation. So first of all, I'd like to talk about the background of our research project and the basic research ideas for our project. So as a background, there are many services utilizing psychological effects and cognitive biases. And also, I think such kind of services will becomes many and many in the future. So just because that wearable devices have been shown to be prone to cognitive biases, or and including entertainment fields, there are many fields using system utilizing psychological effects in the future. So in such condition, this kind of such services utilizing psychological effects vary widely in effectiveness from person to person. So some of people, some of users have a reverse polarity of the effect. So it's a very dangerous things. So I'd like to talk later. And our research project's basic idea is that it may be necessary to know or do screening its effectiveness in advance according to the individual. And also, our basic idea is that brain structures can be used as indicators to know the effectiveness in advance. So finally, we'd like to construct a framework for the safe dissemination of highly effective services in a personalized manner. Okay, so I'd like to show an example of information presentation utilizing the psychological effects, named the false bioinformation feedback. Yeah, false, yes. And supporting the wearable computing environment, wearing the heart rate sensor or some kind of vital sensor, and see the sensor data every time, everywhere, and so on. So in this kind of situation, could you see this graph? Usually, the heart rate is stable, for example, 60 beats per minute or something. And our system, our information presentation technique can change the actual data and false data. For example, this is actual heart rate is 60, stable. So, but the system showed the increasing information. So heart rate increasing and increasing. For example, 60, 65, and 70, and so on. So then, by seeing the increasing heart rate information, actual user's actual heart rate will be also increased. Yeah, just by seeing the information. So this is very dangerous things. So just by seeing the information, the actual vital condition, actual vital data can be changed. So this kind of information presentation technique can be used in good way. For example, increase the heart rate before the physical training is very effective to keep healthy. And there are many kind of services utilizing the psychological effect in good way. So, but at the same time, I'd like to show the 60%, 20%, 20% rule. Like this. And 6% of, for example, in this kind of service, so we conducted several experiments using many users, and so by conducting this kind of experiments, 60% of participants are expected person. So expected person means the act as imagined result. For example, by seeing the increasing heart rate, the actual heart rate will be also increased. So this kind of people, the expected person. And also there is a 20% of a no effect person. So it means that this kind of person has not affected by seeing the information. Yeah. And the most important thing is that there are 20 unexpected person. So unexpected person means, yeah, in other words, there is uh, the people has a reverse polarity. For example, by using this example, so if the by seeing the increasing heart rate, the reverse polarity person, the heart rate will be decreased by seeing the increasing information. So as I said, this is the reverse polarity as expected. So this kind of unexpected person is yeah, about 20% in the experiment. So for writing a journal paper, I think it's okay. So 60% is effective. So the 60% of participants work. So our proposed technique can work. Yeah, 60% of a person. Okay, it's a very good result. So, but yeah, considering the actually implementing this kind of services in the society, so there may be a very serious problems. So as I'd like to show using the slide. So there's a expected type, 6% of expected type person and 20% of unexpected type person. So there are many people. And for using the conventional services, so it means that the services without psychological effects. Okay, so the services works well for both of types. So both of people in yeah feel happy to use the services. But there will be so many services utilizing cognitive bias or psychological effects. So expect type person yeah feel happy or more happy. So this is very effective services. So yeah, they are very happy. But for unexpected type person, so the purpose of the services work in reverse polarity. So it's very difficult to be used for unexpected person. So this kind of person feel unhappy and yeah, they cannot use the services, or moreover, the physical health may be affected, maybe badly affected by using this kind of services. So this may be, yeah, we call this new divide, the cognitive bias divide, and we should solve this problem before propagating this kind of services using psychological effects. So our basic idea of the research is to propose a predictive indicator. We should place the predictive indicator before using the cognitive bias-based services. So this means that yeah, just a way of screening. So you or some people is a distinguished expected type or unexpected type with a very small small training or something. Yeah. So and this predictive indicator shows okay you are expected type person. It's very easy. It's that kind of user should use the cognitive bias based services. And also, a predictive indicator may say that, oh, okay, you are an expected person, so just you have a reverse polarity. So in such kind of cases, so there are many types of yeah way to use this kind of service. So for example, yeah, one way is okay, you are an unexpected type person, so you shouldn't use this kind of this service. And also, yeah, okay, you are an unexpected type person, so please configure the parameter of the cognitive bias-based services to fit you. So such as to by using such kind of predictive indicator, expected type and unexpected type. But so both types of the person can use this kind of services happily, and so. And our research project, the basic idea of our research project is a brain structure can be worked as a predictive indicator for screening the effectiveness of the services using psychological effects. So based on the this figure, so I'd like to explain the role of each group. So our research project consists of 3 groups: Terada group and me, and Hosoda group and the Yanagisawa group. And the Terada group has a role to propose many kind of information presentation techniques and establishing the wearable system platform for evaluation. And the Hosoda group directly worked on the establishment of interaction acceptability screening technology using brain structure. And the Yanagisawa group worked on the application research for empirical evaluation. So Yanagisawa-san worked on is a CTO of a professional entertainment company. So the application research is very practical. Yeah. Also, so I'd like to show the summary of achievement for each group for these 5 years. For our group, Terada group, we published more than 50 new information presentation techniques using psychological effects. And also we published more than 30 journal papers. Yeah. Such as subjective time control and motivation control and so on. And we also constructed a new sensing platforms such as nasal sensing, saliva sensing, and manipulatable auditory perception platform, and so on for the evaluating the information presentation techniques. And also we conducted many information presentation evaluations for commercial products or something. For example, we conducted the evaluation about the optimal font for wearables, and so loss of some source localization by hearables, and so on. Yeah, this is also very strong impact on the society. And for Hosoda group, her groups achieved more than 10 acceptability screening using brain structure. For such as individual differences in long-term performance, the ability to persist called grit, prediction with high probability in advance based on brain structure information. So concretely, so frontal pole part. And also she working on screening courage stress for mental illness due to COVID-19 and so on. Yeah. And also Yanagisawa group achieved that actual application of information presentation techniques to professional entertainment stage technologies. This kind of technology is actually used in concert at the 500,000 audience concerts, very big concerts. Actually, our technique was applied. And also, his group established the design guidelines for LED dance costume based on the concept of apparent dependability. We newly proposed concept. Okay, so this is a two-dimensional map of our individual research results. So they have been published in more than 40 journals. In this figure, the vertical axis indicates whether the research is a social implementation or a fundamental experiment. And the horizontal axis indicates whether they are an existing presentation method or a novel presentation method. So the color indicates which team conducted the study, And the black square indicates that the subject underwent an MRI and that we did screening research as well as information presentation. So since we don't have time to explain all the studies, so we will pick a few research up and explain them here. The first one is about VR acceptability. So this study was published in Scientific Report. This study is about new technology acceptability and its screening. So please imagine sports training, for example, badminton training. So conventionally, there was basically a single training method. So in the figure, training method X, and everyone practiced using that training method. In the future, new technologies may bring many training methods. However, whether or not the training method fits the user will vary from person to person, and this can only be determined by actually trying the new training method over a long period. For example, in this case, the new training method Z is very effective for the user A, but training method Y is not so effective. So it's very difficult to be predicted. So as an example of our new training method, so we have developed a badminton training system using VR. This training method does not use an actual racket or shuttlecock, but only in VR. Yeah, they wear the VR goggle and they don't use any physical racket and shuttle. So what do you think about this training method? I think that people are afraid to try this kind of training because they don't know if it's effective or not. So in that case, usually people select the traditional, conventional training method. So in our study, so we actually conducted an experiment using this training method. First, as a pretest, badminton's serve-receive ability was measured using an actual badminton court. And next, they predicted using only VR for 4 weeks. And finally, the same ability test as a pretest was conducted. So this experiment shows to what extent training with VR was effective in improving the ability. So the resulting graph indicated the participants were classified neatly into two groups. The group on the right is a group whose scores improved. In other words, those group are people who had acceptability for training with VR. On the other hand, the group on the left side is those who showed little improvement. So the left-hand side people, the people shouldn't use this training method. In this way, because the acceptability of training differs from person to person, so it's difficult to select new training if the acceptability is not known in advance. And new training is not likely to be widely used in this situation. So therefore, a method for knowing acceptability in advance is necessary for us. So we tested the hypothesis that brain structure can be used as an indicator of this. So as a result, we found a strong correlation between the size of specific brain regions and the brain VR training scores. So in other words, measuring brain structure with MRI can tell you if you have the acceptability for training with VR. So using this technology, we can conduct an acceptability check before actually selecting training method. And this will improve the training efficiency of all people by allowing them to select their own training method with confidence. In this case, we know that training method Y is not acceptable for the user A, and yeah, you shouldn't use this training method. Yeah. As an example of other screening studies, so we conducted a study to screen individual differences in the effect of classical conditioning, made famous by Pavlov's dog, using brain structure. Yeah. And proposed a method to improve mental sports scores, applying the classical conditioning using indicated by brain structure and so on. So we also found that the degree of the Dunning-Kruger effect, it means that famous effect, the more you can't do, the more confident you are. So it can be estimated using the same kind of brain structure. Next is a study on sense of visual dissonance and the guidelines for LED costume related to the Yanagisawa group. So in this experiment, we use the LED flags, which are very impressive displays because of their flattering images. So, but they are also fragile when used in stage performances. So we conducted an experiment to clarify the conditions under which the audience would be able to aware if a part of the LED flag is broken. So in reality, we have experimented with a variety of patterns. So, but there are two examples. In this flag, a certain number of LEDs are broken and do not light up. In this case, the video on the left side here shows the content scrolling horizontally. Yeah. And while the video on the right shows the content of scrolling virtually. Yeah, like this. So there's a broken part. So we conducted the evaluation about how the audience are aware of broken LEDs or so. So the evaluation results shows that when the direction of broken LEDs and the direction of animation are same, so such case, so wiring is so that when a wire is broken, the broken LEDs are dispersed, so that the failure is less likely to be detected. Like this, yeah. Thus, even when the same number of LEDs fail, whether or not the failure is revealed to the audience varies depending on the wiring method. And we have proposed a framework to estimate this in advance based on the animation content. Okay, so skip. And yeah, as another research result, we developed a guideline for building LED costumes based on the results of long-term operation of a dance costume with LEDs encrusted all over the body. Yeah, and published it in the Journal of Designs. So we have confirmed that the costumes that follow our 16 guidelines reduce failures by 80% compared to previous costumes. So yeah, I don't have time to explain the detail. So, but this is performance with LED costume created according to the guidelines. Very impressive, but this costume will not problem. Performance is so heavy. Yeah, right. The next is a study that investigated commercially available wearable information presentation devices. So, in recent years, a large number of hearable devices have appeared on the market, especially those with a transparency mode, features said to be safe because they allow the user to hear not only music but also external sounds. However, our research found that the transparency mode of many commercial hearable devices can lead to losing localization of the sound source direction. In particular, it is dangerous to walk outside in the state because the front and the rear sense of direction is often mistaken. On the other hand, we hypothesized that the reason for this is that the head transfer function is distorted by the hearable devices. So we have confirmed that localization sensation can be improved by incorporating a process that corrects the head transfer function in the earphones. So these results were published at the IEEE Access. The next is natural conditioning through the use of UI, user interfaces. So in this study, we found that when reading ebooks, people who use an interface that allows them to turn pages by blinking. So blinking is associated with page turning, yeah, in using ebooks, and it causes them to blink when turning pages, even when reading a paper book. So in other words, conditioning occurs spontaneously depending on the interface one normally uses, and conditioning also influences other activities. The next is natural conditioning through the use of user interfaces. Okay, in this study, we found that when reading ebooks, people who use an interface that allows them to turn pages by blinking. Yeah, so blinking is associated with page turning action. And we found that it caused them to blink when turning pages, even when reading a paper book. In other words, conditioning occurs spontaneously depending on the interface one normally uses. Yeah. And this conditioning also influences other activities. Finally, I explain some of the features of the sensing platforms we have built. We have built a number of sensing platforms that use novel methods to measure the effects of information presentation. For example, we have developed a device that detects detail of stress and breathing by placing a small temperature sensor in the nostril. This device. So, we also developed a device that measures saliva circulation, yeah, using infrared, and a device that uses a stress sensor to measure swallowing movements. Each of which we have used for evaluation, and all of them were published in the journals and the international conferences. We have also implemented a framework for manipulatable auditory perception. So this framework was implemented on a hearable device and allows the user to freely process hearing sounds. So depending on the configuration, ultrasonic sounds can be heard as audible sounds, or multiple bands of sounds can be layered, and so on. So there are many functions to control the hearing perceptions. So using this framework, we have realized the mechanism for effective bat-like echolocation with ultrasound for blind people. So these results have been published in IEEE Access and PLOS One and so on. Yeah. Okay, here's a conclusion. In order to establish a new research field called cyphermatics, so this project promoted the research on the psychological effects of information presentation and the screening of degree of these effects. So as core technologies, we propose a number of new information presentation methods and technologies to screen for acceptability and confirm their effectiveness. Furthermore, we confirmed that the proposed method work effectively in a variety of real-life situations, yeah, especially in entertainment field. And we achieved that more than 30 new cognitive bias-based information presentation methods, and we publish more than 200 research papers and 150 presentations, and we got 30 awards in the society, and more than 80 news reports. Yeah, that's all. Thank you.